All right, thanks for coming back. We're going to look now at some examples of finding absolute or global extrema values of functions. And I'm just going to give you three. And these are all on a closed interval. And remember where those absolute extrema might exist. They might exist where the derivative is 0, where the derivative is undefined, or at the endpoints. Those are things you should definitely have in your notes for places where you might find absolute extrema on a closed interval. Okay, so let's just go ahead and find some candidates. Let's go ahead and find out where the derivative is 0 or undefined, right? I can see the endpoints right there. That's a no-brainer. But let's check out the derivative. And if you have some intuition about what this graph looks like, you're probably already know pretty much what we're going to find here. I know that this is linear and it's never undefined. I was just letting you know that I was checking. And then over here, if x is 1, it looks like our derivative is going to be 0. So we have three candidates whose y values might be the absolute highest or the absolute lowest. So we're going to use what's called the candidate method. And remember, you do have to show how you found your candidates. Our candidates will be 1 and the endpoints. Okay, and all we're going to do is plug those back in to find the y values and see if they truly are a min or a max. So when I plug in a 1, I'm getting that the f of x value is 0. When I plug in a 2, I'm getting that the f of x value, a negative 2, the absolute value is, the value is 9. Okay. And then when I plug in a positive 2, I'm getting that the value on this graph is 1. And those are the only places you might have the highest or lowest point. So the highest one, we're going to say that our absolute maximum or our global maximum is 9. Remember, it's all about the y value. And it looks like our absolute minimum or our global minimum is 0. That's the lowest this graph is going to go. If you're not sure, you can graph it either in your head, it's a parabola that opens up, or you can graph it in real time. Okay? Okay, let's move on and look at the second example. Find the absolute extrema of this function on this closed interval. So we're going to look for candidates again. I think we already have two candidates, -1, -2, and 3. And now we're going to have to find the candidates that occur when the derivative is 0 or undefined. So let's see, I'm getting 2/3 x to the drop it down a power. So that's -1/3. And if we need a better look at that, I'll rewrite it so we can see that that's really just a 3 over the third root of x. It's 3 times the third root of x. Okay, so that's what we got. We need to figure out where that would equal 0 and where that might be undefined. Now, I think it's safe to say that this is going to be undefined when x equals 0. And the only way this fraction will be 0 is if the numerator is 0. And I don't think 2 is ever going to equal 0, not in this universe. So I'm going to go ahead and cross that off. We're not going to get a candidate for that. And then we're going to go ahead and check out our candidates. Our candidates are 0, where the derivative is undefined, and of course the endpoints, because we're on a closed interval. And then we're going to go ahead and plug those values in. If I plug in a 0, I get a 0. When plugging in a -2, I'm getting a third root of 4, right? -2 squared, and then the third root. And then for plugging in a 3, remember, we're looking at points on the actual graph of f. So if you plug these in here, you'll just get the values of the slopes. So the actual value on the graph, when you plug in a 3, is 3 squared is 9, and the third root of 9 is, well, in my book, it's the third root of 9. And I think that it's pretty easy to tell which one of these is going to be your absolute max. And you can put this in your calculator to verify. I would strongly suggest that you do. And then this one would be the absolute min or the global minimum, and make sure that you are remembering that that's the y value that we're looking for those. Okay, looks like I've just got one more example for you. You can pause me and go ahead and get the candidates yourself, right? I mean, that would be a great way to start practicing and making sure that you know this stuff, not just kind of daydreaming while Ms. Weber blabs at you. I know it's easy to do. In class, I can really get on you about that, but here I have a harder time, so, work with me. Alrighty, so the absolute extrema. So I'm going to go ahead and look for candidates by finding where the derivative, let's see, that's 12x to the third minus 12x squared. And I'm going to have to find out where that's equal to 0 or undefined. I know that this is never undefined. It's a gosh darn polynomial. There's no holes or asymptotes or anything going on there. So we're not going to find any candidates by looking for where this cubic function is undefined. But I think we're going to find some good stuff when we look for where that derivative equals 0. And I can take out x squared there. Okay, so it looks like we've got two decent candidates there. So let's go ahead and try out all our candidates. X's, and then we'll find those f of x values. And we're just looking there for the absolute highest or lowest. So there can only, be one of each, right, at the most. Let's see, I'm going to go ahead and plug in a 0, a 1, a -1, and a 2 because -1 and 2 are the endpoints. And when we plug in a 0, I'm getting 0. Remember, we're plugging in up here for actual high points or low points on the actual graph of f. Those will occur where slopes are 0 or undefined, right? Smooth mins or maxes or pointy mins or maxes. Okay, when we plug in a 1, my y value, I believe, is -1. Plugging in a -1 is going to yield us a y value of 7 at that left endpoint. And then at the right endpoint, wow, I think we're up there at 16. Okay, and from that, provided I did my arithmetic correctly, apologies if I didn't, that App's first person to email me and tell me that gets bonus points. The absolute maximum of this graph, the highest y value, looks like it's 16. And the absolute min looks like it occurs when x is 1, and it would be a y value of -1. All right, folks. Thanks.